Well, we are now on live on YouTube, and we are going to start then the defense session of the candidate Roberto Armstrong Jr. Firstly, I would like to thank the members of the committee members to be here with us, allowing Roberto to have the evaluation of his thesis. I would first thank Professor Renato Samir Assad, that is here from the University of São Paulo, Dr. Mário Abud Filho, that is from Faculdade de Medicina of São José do Rio Preto, and also Dr. Cyril Moores from the University of Groningen. I would also like to thank Henry Livni, that is the supervisor of Roberto at the University of Groningen. The thesis of Roberto is part of the double degree agreement between University of São Paulo and University of Groningen. Last week, he has his defense in Groningen, and today he is going to be defending his thesis here in Brazil. In order to start, Roberto is going to hold a presentation at maximum time of 60 minutes in order to present the main results of his thesis. So Roberto, the microphone is yours. We are going to share the presentation then, and then we pass to the Arabic session.
First of all, I would like to thank the committee member here present to judge my thesis, titled The Role of Estradiol in the Maintenance of the Brain-Dead Organ Donors, from Pathophysiology to Treatment, under supervision of Ana Cristina Braicalfalopa and Henry Leuvenink. As Ana mentioned, this PhD is in a double degree, a partnership between University of São Paulo and University of Groningen in Netherlands. This presentation contains 6 chapters, and I will discuss the main results from each chapter later. The organ transplantation is the treatment of choice for end-stage organ failure. This kind of treatment.
Eu não sei se é só o meu, mas o slide não está mudando aqui.
Oh.
Só está no título ainda. É isso mesmo?
No. It's not working, then we are going to stop the sharing and start again.
Ok.
Let's try
com licença, na hora de compartilhar, compartilhe a tela do computador, assim irá mudar os slides.
Ok.
O primeiro item.
Is it working now?
Yeah, I think so.
Perfect like this.
But here it's not working now. Okay, now it's working. Yes. So let's start again.
Yeah, again. So thanks the committee member here present to judge my thesis, titled The Role of Estradiol in the Maintenance of the Brain-Dead Organ Donor, from Pathophysiology to Treatment, under supervision of Ana Cristina Braicalfalopa and Henry Leuvenink. This PhD is in a double degree, a partnership between University of São Paulo and University of Groningen in Netherlands. This presentation contains 6 chapters, and I will discuss the main results from each chapter later. The organ transplantation is the treatment of choice for end-stage organ failure. This kind of treatment provides longer life expectancy and better quality of life for the patient. However, the main current challenges are the reduced viable organs for transplantation and the clinical outcomes after the transplantation. And despite the organ donation incentive policies, Brazil is just the 26th in the list of the number of effective donors per million of population. And despite the continued growth of the effective donors in Brazil, this main demand is still higher than the number of transplants performed. In the last year, we had 10,639 potential donors, but only 31% become effective donors. Regarding the non-effective donors, we lost 31% by non-consenting families and 69% correlated with clinical issue. It's important to highlight the most organs for transplantation come from the brain death donors. That's the reason why we have to understand better the pathophysiology of the brain death. So the brain death leads sympathetic storm, hormone dysfunction, systemic inflammation, and activation of coagulation, resulting in a morphofunctional impairment and reduction of organ viability. In addition, the literature describes poor outcomes to male recipients from female donors, suggesting an important biological effects involving the donor organ and the recipient environment. In this context, the aim of my thesis is to describe the sex differences and the effects of female sex hormone modulation on systemic inflammation and organ injury in brain dead donors. For all studies, we use restar rats, 8 weeks old, males and female rats. It's important to highlight the female rats we use during the high estradiol concentration of the estradiol cycle. Our brain dead model, we use isoflurane 5%, and after oral tracheal intubation, we maintain the rat with isoflurane 3%. We drill a 1 millimeter hole in the skull to introduce a catheter forward 4F to induce the brain death. And then brain death is confirmed by apnea, maximum dilated and fixed pupils, and absence of reflexes. The chapter 2 is the differential effects of brain death in rat microcirculation and intestinal inflammation, female versus male, publishing information in 2018. The study protocol, 10 days before the experiment, we performed the ovarectomy in female ovarectomized group. The time 0, we induce the brain death, and then we have the female group. As I mentioned before, this group we use during the high estradiol concentration, the female ovarectomized group, and the male group. We quantify estradiol and corticosteroid concentration. Female rats submitted to brain death present a reduction of estradiol due to the break of hypothalamus pituitary ovary axis. And all rats submitted to brain death present a reduction of corticosteroid related to the break of hypothalamus pituitary adrenal axis. In the context of mesenteric microcirculation, female rats present a preservation of perfusion and blood flow. And this data was correlated to the expression of endothelial nitroxide synthase. The inos plays an important role in the local regulation of vascular tone and blood flow. However, the same group presents a higher expression of deuterin-1 that play a pivotal role in the vasoconstriction, fibrosis, and many inflammation. In parallel with this data, the female rats present a higher expression of ICL1, an adhesion molecule, and higher leukocyte infiltration. So to conclude this chapter, the high estradiol concentration before the brain death results in an expression of endothelial nitroxide synthase, resulting in a relaxation of the endothelium and preservation of the macrovascular perfusion and flow. However, after the brain death, due to the acute reduction of estradiol, we evidence a higher interaction, higher leukocyte endothelial interaction, and higher leukocyte infiltration to the intestinal tissue. So, if the acute reduction of estradiol results in a higher inflammatory response, our hypothesis is if we treat the female donor with estradiol, we could modulate the inflammation. So we have two main questions to answer. Is avoiding the lack of estradiol will be able to modulate the inflammation triggered by brain death? And then to answer this question, we have the E2T0 group, rats submitted to brain death induction and administered 17 beta estradiol immediately after the brain death confirmation. And the other question is is the treatment with 70 estradiol would be able to revert the inflammation triggered by brain death? And to answer this question, we have the E2 T3 group, rat submitted to brain death induction and treated with 70 estradiol after 3 hours of the brain death induction. It's important to highlight we use the most organs for transplantation, the main organs for transplantation: the heart, lungs, and kidneys. Chapter 3 is treatment with 70 estradiol protect donor heart against brain death effects in female rats, published at Transplant International in 2020. For this study, we use 4 groups: the sham group, rats submitted to trepanation without brain death induction, and received during 6 hours volume replacement. Time 0, we induce the brain death. And then we have the brain death group, rats submitted to brain death induction and received during 6 hours volume replacement. A2 T0 group, rats submitted to brain death induction and administered 70 estradiol immediately after the brain death inflammation, received during 6 hours volume replacement and 50 micrograms per ml of estradiol. And the E2 T3 group, rats submitted to brain death induction and treated with 70 estradiol. The first 3 hours of the brain death, these rats received the volume replacement, and after 3 hours of brain death, received volume replacement plus 50 micrograms per ml of estradiol. We quantify estradiol and corticosterone. As I mentioned before, the brain death present a reduction of estradiol due to the break of hypothalamus pituitary ovary axis. The E2 T0 group receives estradiol immediately after the brain death, present a higher estradiol concentration 3 and 6 hours of the brain death. In the E2 T3 group, rats receive estradiol after 3 hours of the brain death. We see higher estradiol concentration in the end of the protocol. Regarding the corticosterone, no significant change was observed among the groups submitted to brain death. Regarding the white blood cell counts, the sham and brain death group present a higher leukocyte circulation, mainly in neutrophils, and estradiol treatment was able to avoid a leukocytosis in both treated groups. Regarding the histopathological analysis of cardiac tissue, the both treatment protocol was able to reduce the leukocyte infiltration and hemorrhage in the cardiac tissue. Also, both treatment protocols was able to increase the endothelial nitric oxide synthase, an important endogenous mediator of cardiovascular protection. And both treatment groups presented lower values for ICAL1 and adhesion molecule. Regarding the cardiac tissue injury, the treatment during 6 hours decreased the release of troponin-1, a sensitive and specific marker of myocardial injury. And regarding the apoptosis, the treatment during 6 hours decreased the expression of caspase-3, a pro-apoptotic protein, and increased the expression of BCL2, an anti-apoptotic protein. So, to conclude this chapter, the estradiol treatment was able to reduce the leukocyte infiltration into cardiac tissue, and regarding the damaged myocyte, the estradiol treatment was able to avoid the apoptosis, to reduce the apoptosis by reducing the expression of caspase-3, a pro-apoptotic protein, and increase BCL2, an anti-apoptotic protein. Chapter 4 is 70 estradiol treatment protects lungs against brain death effects in female rat donors, published in Transplantation in 2021. In this study, we use the same study protocol as I mentioned in the previous chapter. The both treatment protocol was able to reduce the cell counts in bronchoalveolar lavage And the treatment during 3 hours was able to reduce the leukocyte infiltration in the intravital microscopy technique. Similar phenomenon was observed in the lung histopathology analysis. The both treatment protocol was able to reduce the leukocyte infiltration, and the treatment during 3 hours was able to reduce edema and hemorrhage. In analysis of the chemokine in the lung tissue culture, the both treatment protocol was able to reduce chemokines such as MIP1 and MIP2, a chemokine for monocyte and macrophage, and SYNC1 chemokine to neutrophils. The treatment during 3 hours was able to reduce the expression of ICAN1 and VCAN, both important adhesion molecules. The treatment during the both treatment protocol was able to downregulate the gene expression of IL-1 beta, and also the treatment during 3 hours was able to reduce the expression of IL-1 in lung homogenate. Similar phenomenon was observed regarding the TNF-alpha. The both treatment protocol was able to downregulate the TNF-alpha, and the treatment during 3 hours was able to reduce the cytokine, the lung homogenate. Regarding the metalloproteinase, the treatment during 6 hours decreased the metalloproteinase, the gene expression of metalloproteinase, and both treatment protocols was able to reduce the metalloproteinase activity. It's important to remember the metalloproteinase play a prominent role in pulmonary inflammation. So to conclude this chapter, the estradiol treatment was able to reduce the leukocyte infiltration, the expression of adhesion molecules, edema, hemorrhage, cytokines and chemokine release, and the expression and activity of the metalloproteinase. The chapter 5 is protective role of 70-bit estradiol treatment in the renal injury in female rats submitted to brain death, published in Annals Translational Medicine 2021. In this study, we use the same study protocol as I mentioned in the previous chapters. The estradiol treatment was able to improve the renal function, observing the reduction of creatinine in the serum in the estradiol treatment during 3 hours. Regarding the leukocyte infiltration, the treatment during 3 hours was able to reduce the MPO, mainly released by neutrophils. And regarding the kidney injury, the estradiol treatment, both treatment protocols was able to reduce the kidney injury marker, mainly expressed during the acute injury. And this protein is correlated to apoptotic cell clearance. And in parallel of this data, we see lower values in both treatment protocols in caspase-3, a pro-apoptotic protein. Regarding the complement system activation, we quantify C3 that plays a central role in the activation of complement system. The treatment protocol, the treated group during 6 hours presented lower values for C3. In the end of the complement system cascade, the membrane attack complex, it's classically known as a cytolytic effector of inactive and adaptive immunity that forms a pore in the plasma membrane of pathogen or target cells, leading osmolysis. The estradiol treatment during 3 hours was able to reduce the formation of this complex. In the context of the complement system receptors, many of complement system effects depend on the complement receptors expressed in the leukocyte and the parenchymal cells, which by recognizing complement-derived molecules and promote leukocyte recruitment and activation. The treatment during 3 hours was able to downregulate the expression of C3a receptor and C5a receptor. Regarding the metalloproteinase, the major physiological regulator of extracellular matrix degradation in the glomerulus, the estradiol treatment during 3 hours was able to reduce the metalloproteinase 2 and 9. The treatment during 3 hours was able to reduce the IL-6 on renal homogenate, and lower values was observed in the same group in the IL-6 gene expression. So to conclude this chapter, the treatment with estradiol was able to reduce the renal injury, the complement system activation, the cytokine release, and so far we analyzed the effects of the brain death in vivo, but the literature described a technique called an isolated perfused kidney model. Such technique allows us to evaluate the function of the organ without a systemic influence, such as blood pressure, hormone, and nerves, to be studied. So in this chapter 6, we studied the evaluation of sex differences in acute kidney injury after the brain death using an isolated perfused rat kidney model. We have 4 groups: the male Shen group, female Shen group, male brain death group, and female brain death group. As I mentioned before, the female we used during the high estradiol concentration. The both Shen groups, we maintain their rats with 30 minutes. In the brain death group, we induced the brain death around 30 minutes, and we maintain the rats during 4 hours. After the first part of the protocol, we perform the nephrectomy, and the left kidney, we connect in the isolated perfused setup. Regarding the renal flow, the male brain death group presented lower values for flow during the renal perfusion. Regarding the inflammatory cells, we performed the analysis of MPO, mainly released by neutrophils. The brain death increased the expression of MPO in males and females, in the glomeruli and interstitium. After IPK, we see higher expression MPO, mainly MPO in males brain death, and male and female in the interstitium. And the main difference between the sexes is observed after the IPK. The male brain death group present a higher expression MPO, and female brain death groups present lower values for MPO. In the quantification of IL-6 in perfusate, both genders present a higher IL-6 release on perfusate. Despite the non-significant difference in the creatinine clearance in vivo, we observe a reduction of creatinine clearance during the IPK in both groups submitted to brain death, male and female. So to conclude this chapter, the preliminary findings in our study highlighted the important sex differences after brain death and IPK, especially in the maintenance of the renal perfusion and inflammatory response. So to conclude this presentation, the data presented here allow us to reinforce the presence of important sex differences on the repercussion of the brain death. The female sex hormones, especially estradiol, exert an important influence on the repercussion caused by brain death in female donors. The acute reduction of estradiol leads to an exacerbated inflammatory response. The maintenance of the serum estradiol levels due to the treatment immediately after the brain death induction, resulting in a non-progression of the inflammatory process in the heart, lungs, and kidney. In addition, once an inflammatory process was established, the late treatment was effective in reducing the inflammation in the tissue injury caused by brain death in all organs studied. We see the estradiol was able to reduce the release of inflammatory molecules, the leukocyte infiltration, endothelial function, and the tissue injury. Thus, the treatment with Estradiol may contribute to maintaining or improving the quality of the organs for transplantation. Thank you very much.
So now we go on with the session, and I would like to first to clarify the way it's going to be held, because the professors from Groningen are not used to our way of doing this. So first, you are going to have a dialogue, or you can share your questions first and Roberto asks later. So each committee member has 20 minutes to do the questions, and Roberto is going to have 20 minutes to answer them. You can do it like a dialogue and have 40 minutes for all the conversation. You choose the way you like most. You can ask everything and he answers everything, or you can talk about the work and have shared opinions and talk about it. And normally we start with the professor from far away. So I'm going to invite Cyril to Professor Moores to start. You are going to have 20 minutes to talk to Roberto, or you can share your opinions in 40 minutes of conversation. I'm going to, you can put on your microphone and then start. Thank you for your presence here.
Well, thank you very much for inviting me to this committee. It's really an honor. And Roberto, I read your thesis with pleasure. It's a very, very nice collection of diverse studies with one same topic. I like that very much, but you have various organs, various aspects of the same notion. So yeah, it's a pleasure to read. And of course, while reading, I came up with a few questions. I would strongly prefer to have a dialogue, as you may have expected, because that's what we are used to. And I'm not so good at speaking for 20 minutes myself. So let's have a dialogue if that's okay for you.
Yeah, sure.
Okay. So I'll try to take everything together. And well, I wanted to actually start off with several more general questions. I'll get more to details later on. But while reading your thesis, and especially your introduction and your general discussion, some things occurred to me, and I wanted first to talk to you about those before I will start to go chapter by chapter with questions. Now, maybe something to start off, something completely out of your comfort zone, but I would like to know how you think about this, and maybe you can give some arguments for it. You've been studying brain death, you've been studying sex differences, and you see effects of sex hormones. But I remember that not too long ago, there have been some studies that looked into the duration of brain death. So, and then the funny observation came out that if a patient is brain dead for a few hours, there are all sorts of detrimental effects which you can actually see after transplantation of these organs. However, if the brain death duration increased to 1, 2, 3 days, apparently something happened that mitigated these effects, and these organs performed actually better. For example, Mijntje Nijboer from our group some time ago did a retrospective study on the topic. Now, I was wondering, Roberto, can you perhaps comment on what you think the effect could be and what this could mean for the findings of your studies? Does anything like sex hormones may have a temporary effect, or do you think these are two very separate mechanisms?
Well, thinking first of all, thank you, Professor Moores, to be here and read my thesis. We had several discussions when I was in Groningen, and it was very exciting for me. Regarding your question, thinking first without the treatment, only the brain death comparing male and females. As we see here, the inflammatory response is made appears after the brain death induction. Of course, in a long time, this inflammation could be more exacerbated, probably in females, as we see here, due to the reduction of estradiol. Also, as we see in the first chapter and the second chapter, depends the estradiol concentration of the female. If the woman is pre-menopause, the inflammatory response could be lower in the first hour or day in this female in comparison to the female without this hormone. But I believe in the longer period, the inflammation could be worse in both sexes. That's the reason why we now discussing the treatment. As soon as possible, we can treat with the donor, we can preserve all the organs for transplantation. We see here in the treatment during 6 hours, we treat it immediately after the brain death. The inflammation not progressive. So as soon as possible, we confirm the brain death, we can modulate this inflammation. Not only in the female, but in males too. We see, not here in my thesis, but in the other studies from our lab here in Brazil, we performed the treatment in male rats, and the estradiol treatment was able to reduce the inflammation in lungs and the microcirculation in males too. So we can discuss this kind of treatment not only in female, but in male too.
Okay, I understand your point. But can you remind me of what you think is the effect or the mechanism behind the fact that, as a result of brain death, estradiol drops in females? Can you highlight the mechanism of that for me?
The reduction of estradiol?
Yes. How does it happen?
Once we have the break of the hypothalamus hypophysis ovarian axis due to the trauma, we lost this positive feedback to ovarian, and then we see the reduction of estradiol in few hours.
Yeah. So okay, so it's a break of this axis, right? And
Yeah.
Is there any logical reason why that would come back if you wait for several days, for example? Or is this axis disturbed and will it stay disrupted? What do you think?
Well, once we break this positive feedback, we have the consumption of estradiol, mainly by the brain, and then we observe the reduction. Of course, we don't have this data in the human, but I believe we can see the same phenomenon in the woman in the clinical, as we observe here in the rats. But it's something we can measure learning. We know we have the incredible bank with human sample. We can perform this quantification of estradiol to confirm this reduction in female patients too.
Yeah. So, but you do think it will be permanent if it will not come back if you wait longer. So, if I'm not thinking clinically, and there is some sort of beneficial effect of waiting longer, then it's probably not related to the things you found. It must be something else then.
Yeah, probably we will observe this reduction. I believe it's something we see in the other hormones like C3 and C4 or insulin. Then we perform at least here in Brazil, we perform the treatment, the requisition of the T3, T4, insulin, vasopressin, in order to maintain this patient or the future patient for donation, to preserve the hemodynamic and preserve the organ for transplantation. So I believe the same logic to the reduction of the hormone in the estradiol.
Yeah. So you're actually highlighting that there are many more effects of brain death, right? So that it's a multifactorial, and you've been looking at various specific aspects in a specific time period. Okay, enough about this. Now you studied various organs, which I really liked. And if you have some sort of overview over all your studies now, what organ do you think, based on your data, benefits most from intervention? Or maybe let me put it even earlier, which of these organs is most affected by brain death and estradiol depletion in females? What's the most sensitive organ to this?
Sorry, if we improve the quality of the organ, all organs is perfect. But it's hard to mention one organ was benefit more by the treatment. We see very good results from each organ, the heart, the lungs, and kidney. But I believe the kidney was the most, the lung, we see more positive effects. Once is the organ most vulnerable for inflammation, mainly by brain death. But the heart, we see a good results too, and kidney also. It's important. I believe the most mechanism behind the estradiol treatment is the release of the inflammatory mediators and the preservation of the endothelial function. We see once we preserve the endothelial, we reduce the expression of adhesion molecules in the leukocyte infiltration. So we see this effect in the heart, lungs, and kidney. But in the comparing the three organs I treated, I believe the lungs was the most benefit by the treatment.
Clear. I was going to ask you for the mechanism, but you actually already answered that question. So I'm happy about that. So now another question, again, general, coming from a clinician who also does organ retrievals. You talking about brain dead patients, and as you know, there are also donations after circulatory death. You showed the numbers, which are very different in various countries, but the typical DCD donor is also a patient who has irreversible cerebral injury, however, just does not meet all criteria for legal brainstem death. So many biological mechanisms in that donor body may be very similar to brain dead patients. Now, I was going to ask you, do you think that there really is a distinct difference between that controlled DCD donor, that patient still on the ICU, and a proper genuine brain dead donor in terms of inflammatory mechanisms, in terms of estradiol response, etc.? Or may it just be the same?
Well, comparing the DCD and DBD, I believe the inflammatory response is more exacerbated in the DBD. Once the brain death results in the catecholamine storm, we see many effects of the catecholamine storm. We have the hypoxia in the several organs, and then we result in, I believe the mechanism, the trauma is worse in the brain death model than the DCD, from my point of view, and as I read in the literature. So, but looking the possible treatment, anti-inflammatory treatment in the brain death patient could be more effective. I believe in the DCD, treatment in order to preserve the hemodynamic could be more benefit. That's my opinion. I don't know your opinion.
Okay, but I was wondering whether you could come up with a biological reason why there's such a distinct difference, right? Because looking from a distance, it seems very similar. It's just a legal criterion that it's different. Okay. Or is there some black and white biological difference there?
Regarding the legal, it's an interesting question. I didn't thinking about it.
No, well, maybe something to think about. But let me move on to another question.
Yeah.
So I was intrigued by so the sex-specific effects that you found. However, as a simple clinician, I would say, we always thought that in kidney transplantation, much of the difference that we see in sex of the donor towards sex of the recipient is related to size of the organ, right? In general, the female kidney is quite a bit smaller than the male kidney, so you'd rather have a male kidney than a female kidney. Now, I was wondering, does any of this also play a role in the results that you may have found for kidneys, or is that just a completely different mechanism?
Well, in order to perform the transplantation, I believe the clinician have to keep in mind the size of the organ for donation, of course. But here the aim of the thesis is describe and discuss the inflammatory behind the for the transplantation. Of course, in order to we have our idea here is give to you or the physician the better organ for transplantation, and then after discuss if the organ could be better, we can perform this transplantation in male or the female. The idea here is discuss the preservation of this organ for transplantation. Once we have reduced the viable organs for transplantation, I believe once we improve the quality of the organ, the number of the viable organs for transplantation is important. And then discuss the size, the matching, the smaller kidney from the female to the man recipient. We can discuss later. I believe the most interesting here is preserve the organ for the transplantation, the quality of this organ for transplantation. Of course, I remember when I was in Groningen, you showed for us in a presentation, you are developing an app to discuss the possibility of this organ for the transplantation. And you discuss, of course, you show the importance of the size. Of course, we have in mind not only the kidney, but the thoracic organ, the lungs, and the heart. But I believe give you a good organ is the first step to discuss, okay, this organ is good for the man or is better for the woman. That's my opinion.
Okay, now I see your point, Robert. I see your point. So, but I was trying to make the point that it's very multifactorial, right? That's what determines outcome and organ quality. It's not just this one thing, and there may be confounders in that process. So sometimes the size of the organ, especially kidneys, might be partially a confounder of sex differences, right? Because the females have smaller kidneys than the males. But I do agree that what you found is a very distinct effect. I'm quite convinced of that. Now let me move on to chapter 2, if you don't mind. Very interesting study that you present there, and just a few details. But if I look at the methods, I was wondering, why did you come up with 15 in the male group, 16 in the female group, and 12 in the ovarectomized female group? Was that a coincidence, or was it predetermined to be those rather different numbers?
Let me see.
So basically, why wasn't the number of animals in each group the same?
The 15 male and 28 female, this amount is regarding, we have the female to brain death and the female to ovarectomized, the female group and the female ovarectomized group.
Yeah.
Okay.
why wasn't the group size similar for every group? Did something happen, or was that predetermined?
As during the cycle, we choose the female during the estrus and proestrus is the phase during the high estradiol concentration. You have the larger amount of the female rats to have this specific estrus cycle during the high estradiol concentration.
Okay, so the cycle determined whether this rat would end up in the female group or it would be ovariectomized and.
No, we have this animal, and then 10 days before we perform the ovarectomy. Yeah. The female group, only without the ovarectomy, before the experiment, we perform the analysis of the estrus cycle. We perform the vaginal smear to see which phase the rat is in the proestrus or estrus. And then we choose only the proestrus and estrus. I don't know if I was clear.
Yes, sort of. So that is, you're saying that determined the fact that the numbers in each group are different, right? Is that...
It's just to have enough N to perform the analysis. The main problem is find a rat during the high estradiol concentrate. That's the reason why I have a bigger number.
Okay, that is sort of clear to me. Now let's move on to figure 1 on page 20. If I look at these figures, and of course I know that you did statistical testing and you just tested the female versus the male. However, my eye keeps drawn to the female ovariectomized part, and it seems to be in the middle, although you may not have tested it as significant, but it strikes me that it's quite in the middle. And I would have expected that it to be at the same level as the males. Or am I wrong in thinking that?
I don't know. During these 10 days before the experiment, the female randomized may I forgot the word now, but they feel more comfortable with the reduction of estradiol. So probably more days we could find the levels in more close to the male, but it's adaptation to the female group.
Okay, so you're saying that they may still have had some effect of the pre-ovariectomy period that they experienced, which is different from the males.
10 days before is enough we see no estradiol in the circulation. That's the reason why we perform this 10 days.
Yeah. So what does this group tell you then? Well, because you don't really describe it a lot in this paper, right? What do we learn from the female ovariectomized group?
Exclude the estrogen effect, because we see in the female group without the ovarectomy, the estradiol previous the brain death was important to preserve the perfusion. So here, once we see the effects of the brain death, the reduction of estradiol, the estradiol pre-brain death was able to preserve the perfusion. Once they reduced we took off the estradiol, we see not the effect of this hormone, the microcirculation. That's the reason why we have the ovarectomy group. Exclude the estradiol effect of the brain death.
Clear. Okay, thank you. Now, in the same chapter, I was triggered by the fact that you apparently saw that there was a lower mesenteric perfusion as a result of brain death. And as you know, and that happened mainly in male rats, am I correct? That the male rats suffered more from the negative effect of brain death on mesenteric perfusion. Yeah. So you know that we perform small bowel transplants every once in a while. So now I was a bit concerned that should we actually then go for male donors? They're always DBDs, right? They're always brain dead donors. So should we perhaps favor female donors? Because we don't want these vulnerable intestines to be hypoperfused. They're very sensitive to ischemic injury. Does that make sense, or is the effect so minimal that it doesn't really matter?
The data I don't put here in my thesis, but the main differences we suggest the reduction of perfusion in the male is the higher coagulation effect in the males.
Yeah.
In fact, Estradiol previous the brain death was able to reduce the coagulation in the female. That's the reason why we suggest not only regarding the endothelial nitric synthase, but also the coagulation was important to the preservation of the perfusion, the mesenteric. In the other paper published by Correa in our group here, evidence the sex difference in the coagulation. In the male represent more clotting and the clotting formation in the male. In the female, we didn't see a big difference.
Yeah, so this is even more distressing, right? You don't want any coagulation in your small bowel grafts. So would that make the point to using only female donors, or even go for DCD bowel grafts, right? They may not have this effect.
I believe not only here in the mesenteric and the intestine. We suggest the same mechanism in the kidney in the chapter 6. Of course, we have more tests to perform, but I believe the reason we see the reduction in the renal flow in the male kidney could be suggested by the clotting or any other problem in the microcirculation. But it's something we have to evaluate in the future. This paper is not finished yet. We have more evaluations to perform. But I believe one idea could be the same effect in the kidney as we observed in the intestine.
Yeah, so this is really interesting and maybe clinically relevant to several organs, right? Okay, let's move on to chapter 3. Another interesting study. And this is, of course, a bit outside my comfort zone. It's on heart transplants. But still, I mean, many mechanisms are the same. And I have a sort of a general question about this, but maybe you can speculate a bit about it. I couldn't really find it in your thesis, but you consistently show in several studies, also in this one, that estradiol reduction due to brain death in females leads to more inflammation and hence worse outcome after female brain death donor, well, heart transplant in this case. And I keep being puzzled, why does this not relate to males, right? They don't have that much estradiol. They're used to lower levels. So why is it the drop in estradiol that is detrimental and not the absence or a low level? Because I don't get that. Can you speculate on why that is?
Well, if we see the other models or in the clinical situation, the estradiol modulate the inflammation in the woman. We see the estradiol protect previous the menopause. Estradiol protect the cardiovascular system regarding the renal diseases. We see the incidence of renal disease is lower in female than male. That's a reason estradiol protect the kidney also. And then when we perform the brain death, the woman lose this modulation effect. Lose this protection, and then she's more vulnerable for the brain death effects. That's the reason why we discuss the estradiol.
But do the men not need that protection then? Do they have stronger organs?
The reduction is not so. The estradiol for men is not so important. We have the other mechanism behind the protection for us, not the estradiol. That's the reason we discuss male here, the female. The estradiol modulate the inflammation in male. And once we induce the brain death, she loses this effect and then is more vulnerable.
Okay, well, this is really nice, interesting, right? It even more highlights that there are many sex-specific differences, and not just a drop in hormones, but also sensitivity to something and different protective mechanisms. That is really interesting. Now, a very specific question to you about page 34. You mentioned under statistical analysis, and that this accounts for the whole thesis, by the way. You consistently present data as mean plus standard error of the mean. Why? Why don't you use a standard deviation?
Well, being honest, the statistical part is not my kind of thing. Usually I have good feedback from Anna and Professor Luis Felipe. He is enthusiastic of the statistical, and he always give him a strong feedback for me regarding the statistical. It's this kind of way to show the statistical is something we are common use here, and then the magazine, in this case the Transplant International has to use.
So they asked you to use SEMS instead of SDs, right? Well, so in my knowledge, I mean, the standard error of the mean is a measure of the precision of an estimated population mean, and it doesn't tell you anything about the variance in your data. This type of data, you actually should use standard deviations. They look uglier because they have bigger flags.
The way to show the data looks not so beautiful, but I believe you can show good the effects, the brain death and the estradiol too. Yeah,
it probably doesn't influence your conclusions, but if you make graphs, I would suggest you go for the SD.
Okay.
One more question about chapter 3, because you then go on to suggest that estradiol as you suggest it as a potential beneficial treatment for female brain death donors, but which seems logical, of course, given your results, but this is not something you've actually proven. But are you aware of data from other groups that have investigated specifically this and that show that there is indeed a positive effect if you treat with estradiol after brain death?
Sorry, could you repeat the question?
Are you aware of data from other groups, for example, or maybe from your own group, other studies with actual transplantation, for example, or clinical studies even, that already show or suggest that if you treat with estradiol, that this will be beneficial for post-transplant results?
Okay, I see your point. Well, regarding the treatment with estradiol in clinical, we don't have it so far. Probably is a suggestion to do in the future. Treated, I believe the first step is in the clinical, we observe the reduction of estradiol, and then we see this effect, we can think in perform the treatment with estradiol to modulate the inflammation. But the clinical studies treating the donor, we don't have it.
No, it still remains to be seen whether it will actually lead to better transplant outcome, right? This hasn't been confirmed anywhere yet.
Not yet.
No. Okay, let's quickly move on to chapter 5. Now, if you look at page 80, something struck me there. So figure 2. You show that if you look at the bars after 6 hours, so the estradiol, so the E2T3 group, seems to have an even better renal function than the sham group. Can you explain this, or is this just coincidence? So the creatinine is even lower than the one in the sham group, and I couldn't really come up with an explanation for this. Is this just variability in your data, or is it something else?
I believe the possible mechanism is something we didn't discuss, but I believe the possible mechanism is the sham. We have the manipulation, we have the stress of the manipulation.
Mm-hmm.
We have to think in this, right? We perform the things, same thing we perform the brain death without the brain death, of course, but this rat maintain during the 6 hours. We have the stress of the manipulation. Then we can result in a higher creatinine. The creatinine in the serum. But the estradiol treatment was able to reduce here the treatment. But I believe the stress of the manipulation could be result in a higher creatinine clearance.
So you're basically saying that even that estradiol treatment may even reduce something else, like reduce the inflammatory response or whatever stress because of manipulation without brain death. That would be your explanation for this.
Yeah. Here we did the comparison of the sham with the brain death. So we didn't see an injury in the brain death in the sham group. So we see an injury in the brain death. So we use the sham just to comparison to showing the model was effective in use an injury, but not the sham. We don't have an injury. Of course.
Yeah. Okay, fair enough, clear. Now further on chapter 5, as I seem to have understood, you looked at KIM1 as an injury marker, right? And you both looked at gene expression, so RNA, but you also looked at the actual protein with other types of analyses. And now it seems to me that you did find a difference in protein levels as a result of your intervention, but you don't see that on the RNA level. And now that feels a bit like the wrong way around, because usually you do find something in gene expression, but you don't find the protein yet. How come? What happened?
Well, we have to keep in mind here is a kind of photo. We have the phenomenon in the end of the 6 hours. Probably we could find a difference among the groups in the 6 hours. And then we have thinking about the first we have the gene expression to perform the protein expression. So here could be effects of the difference 3-6 hours. So here we see the effect of the protein expression in the 6 hours when we collect the kidney.
Okay, so you're suggesting that the gene expression may already have disappeared, and that now you only see what's left over being proteins. Is that a good? Okay. That I also thought so, but it was a bit confusing to me. Yeah.
Yeah, we are always thinking, if we are measuring the gene and protein expression, we expect first they are like equal, the same phenomenon they both graph, but in the real life, we have to keep in mind that we have first the gene expression to then perform the protein expression. So not always we see the same phenomenon in the gene and the protein expression.
Okay, Mrs. Chairman, how long do we still have? I think 5 minutes or so, or are we already through?
We have 5 minutes.
5 minutes. Okay, then I'll come to my final questions.
Okay.
Well, again about chapter 5, I was thinking estradiol being most effective after 3 hours of brain death induction, right? That's what you sort of found. that may suggest that you may not need to do this treatment in the donor, right? Can you speculate on the possibilities of this treatment being given during, for example, ex vivo machine perfusion to the organ, or even further on to the recipient? And would that complicate the matter, or would it be more effective?
Interesting question. Thinking the E2T3, the idea is thinking in future in the clinical. We have a time to confirm the brain death, of course. Once they happen, and then we confirm the brain death. So the latest treatment with Estradiol was able to reduce the injury treated by brain death. This one is a one topic, and I believe in the real life, in the donor, the treatment would be able to revert the effects of the brain death. And regarding the ex vivo, as you mentioned, in the perfusate, I strongly believe in a positive effect of Estradiol. Once we see also in the other models, in the ischemia reperfusion, the Estradiol was able to reduce the injury triggered by this model, not only in females, but in males too. So, and treated in the recipient could be effective in order to modulate the rejection. It's something we don't have studied yet, but it's I believe the Estradiol could be modulate this inflammation in the recipient.
Okay.
And then I think I missed one question regarding why we see more positive effects in the treatment during 3 hours, right?
That's also an implicit question, yes.
I didn't show this data here, but we studied the receptors, the Estradiol receptors in the kidney. And then the brain death increased the expression of the receptors, mainly the beta, in order to try an anti-inflammatory effect. And then once we have more expression of the estrogen receptor beta, and this receptor is more correlated to anti-inflammatory effects, when we treat it with Estradiol, we combine the more Estradiol receptor beta and then with Estradiol. That would be an idea why we see more positive effects in the treatment during 3 hours.
Okay, that very good answer. That makes it very clear. Thank you. My final question is about what interests me most. And I was a bit disappointed that I didn't find it in your future perspectives. You didn't mention much about ex vivo perfusion, right? I was thinking, oh, this is the opportunity. But given that it might be an opportunity, what would you advise us to do? Like there may be a good opportunity to treat to counteract some of these effects. For example, with Estradiol. Of course, normal thermic perfusion would be beautiful because then it's a sort of physiological environment. Yeah. But it's also cumbersome and expensive. And do you think that ex vivo treatment of organs with, for example, Estradiol could also be done with cold perfusion? Because that's what we do anyway.
Cold perfusion?
Yeah. Would this effect also be mediated in the cold, or do you need function or physiological environment for it?
I believe, yeah, we can use Estradiol in this model. We see the Estradiol modulates the inflammation in several models, not only here in the brain lab, but in the ischemia and the other models in the injury in the organs. So I believe the Estradiol could be used in not only the cold perfusion, but the normal thermic, in order to avoid an inflammatory response and an injury in the organ. So, and then it's an idea to perform a study including Estradiol on the perfusate. But that's the future.
Okay, let's go for that and give it a try. Yeah, thank you very much, Roberto, for the interesting discussion, and good luck with the rest of the questions.
So now we are going to move on, and Professor Mario is the one who is having the microphone open and do his questions to Roberto in the form of dialogue or question and then answer. You talk with Roberto and decide what is best for you. Thank you for your presence once more.
Thank you. Good morning again to the members of this panel and to everyone that is connected to this session. Initially, I want to thank you, Roberto, and your advisor, Professor Ana Brauthaupt-Falopa, for inviting me to be part of this panel together these distinguished professors, Assad, Moyers, and Luvoning. I am really honored to be part of this. Thank you. My discussion, I think will continue in the same line that Professor Moyers started, and maybe could be repetitive, but I think could have some enlightenment. Let's go there. I like it. I read your thesis because, as you may know, is a subject that I like very much and have a special interest. Although I am not a surgeon, I am a nephrologist and work in the setting of clinical transplantation. And as you may also know, that we have now a collaborative project with Professor Luis Felipe Moreira and the team, and I publicly take the opportunity to thank him for that. Regarding our presentation, I thought it was very clear. It covered all this big work done. The quality of the slides were very good. The sequence was didactic, and the hypothesis and conclusion were accurate. Moving to the thesis, and I want to mention that I used the book as a reference and used the PDF to see in details the bar figures. And I think that the book is very nice. It's aesthetic. The format is easy to read, exception to the figures. And the distribution in chapters, and sorry, I couldn't read the 8th chapter in Dutch. But I would like to start with the abstract. You clearly explain the rationale of the whole work and part of your results, but I missed at least 2 lines of conclusion to closure, and something like, well, taken together, our results suggest that, etc., in order that, if, for example, a reader without access to all your material may have a good idea of the whole findings that you have. Moving to, if you want, we talk a lot, a dialogue, please, you can interrupt me.
Okay, feel free.
Okay. In the chapter 1 of the book, you nicely introduce the consequence of brain death for the different organs. It show molecular aspects and beneficial effects of estrogen or estradiol in organ preservation as a modulator of immune response. And from chapter 2 to chapter 6, you present a contribution in this subject through 5 papers you achieved to publish in very good prestigious journals. And I am certain that the referees' major and minor concerns that you receive back certainly tested your knowledge and your patience. And for this reason, I believe that the final step of a paper is the publication. And once you achieve it, it certifies the merit of your work. So therefore, all kinds of questions that I may have would be a simple exercise to fully understand your way of thinking about this subject that has many controversies, as Professor Morris already showed to us. For example, in chapter 2, page 21 and table 1 of the book, chapter 3, page 38 and figure 1b, and chapter 4, page 59, you repeatedly found changes in serum estradiol concentrations, but you also find similar change in corticosteroid. And Professor Morris started this question in this, and you always give much more emphasis in the estradiol concentration, and you don't talk too much about the corticosterone. You have in one of these tables, probably in page 59, a dramatic reduction in corticosterone. And it's reduced almost to zero and was not responsive to the estradiol treatment. How could you explain that? Why you do not emphasize a possible role of corticosterone and give emphasis only on estradiol?
Well, first of all, thank you, Professor Aluno, to read my thesis, and you're always open to discuss with me. Regarding corticosterone, in fact, we didn't discuss in details the effect of corticosterone, but the main topic of the thesis is discuss the brain death, the estradiol reduction, and the estradiol treatment in order to modulate the inflammation. Of course, the reduction of corticosterone help in the exacerbating inflammatory response, and possible treatment with glucocorticoids could be modulate the inflammation. That's a thesis of other researcher from my lab. She's performed the treatment with estradiol plus corticoid in order to modulate the inflammation. But here in my thesis, we are discussing the effects of the estradiol reduction or the treatment in order to modulate the inflammation and the injury triggered by brain death.
I see. But would you believe that could be a balance between estradiol and corticosteroid, or something like that? Or you think that it's an effect only due to the estradiol?
No, regarding the injury and the inflammation, it's both contribute. The reduction of the both hormones contributes to the injury triggered by brain death. And the reposition of this hormone could also modulate the inflammation. So the combination of the both hormones could be effective in order to reduce the injury and the inflammation triggered by brain death. But here, only the estradiol treatment modulate the inflammation, reduce the inflammation. But so far with this data, we can conclude saying the estradiol treatment would be able to revert the injury triggered by brain death. But the quantification, the analysis, the treatment estradiol and corticosterone is something we will discuss in the future.
Okay, because as you know, we use it to give during the not isolated, cold static perfusion in clinical setting, corticosteroid together with the urocolins. We don't have many machine perfusion here in Brazil due to the high cost. But a few centers only have machine perfusion, and we use it mostly the cold static perfusion together with corticosteroids, and used for everyone. in thinking probably in these mechanisms, inflammatory mechanisms that you mentioned. Okay. Professor Moyers asked you about the amount of the samples of animals that you used. I have a different question. How do you arrive to the 50 micrograms dose of estradiol? It was, you had previous studies showing that was the ideal dose, or you read in another paper? How do you get this 50 micrograms dose?
The treatment here in my thesis was based in the previous study published by my supervisor in the schema reperfusion model. Here, the idea was to maintain the estradiol concentration. That's the reason why we give 50 micrograms per ml of estradiol in a continuous infusion. That's the reason why we use this treatment in order to study the modulation of the estradiol effect in the brain death model. But it was based in the previous study already published by my supervisor.
Okay. Well, I like it very much of chapters 5 and 6, obviously, because you mentioned the kidney, you used kidney. And you show that the estradiol treatment, especially in figure 2, page 84, and that treatment after 3 hours of brain death presented a significant reduction in serum creatinine, suggesting that the estradiol was able to prevent and attenuate renal injury. And after 6 hours brain death in female rats, right? And but if you analyze the bars, you see that we are talking about an acute kidney injury model. And I don't know if after you take that kidney and go to the recipient and perform the transplantation, what do you think that happens? Because today we already are allowed to transplant or to accept donors in acute kidney injury, and the outcomes of these kidneys are similar to those without AKI. How could you explain that?
Well, as I mentioned to Professor Moores, our idea is give to the physician the best organ ever. Of course, I don't know much more than you about the real situation, and they are regarding give organs with lower values of the inflammation. But here we are giving a good organ. The idea is give a good organ to transplant. Once we are giving an organ without an inflammatory response in continuous, with a renal function preserved, I believe the outcome, the recipients, could be good as if we are giving an organ 100% good. We are giving an organ to transplant, an organ good from my point of view.
Okay. Looking for the markers, the inflammatory markers you used, I confess that I was a little bit frustrated seeing that some important proteins of stereo inflammatory response, such IL-1, caspase 3, and BCL2, were not much differently affected by treatment. And as we know, these markers are important markers of innate immunity present in the process of steroid-inflammatory response. And we have a special interest in this steroid-inflammatory response because there are a series of events happening just before you put the organ in the recipient. And maybe it's our idea, as I know it's yours, you can treat these events like giving estradiol or giving steroids or giving some IL-1 or inflammation blockers. But your data doesn't go in this direction because, well, if they are not affected, we don't need to treat them. And Professor Moyers, said that you have protein, but you don't have gene expression. We have made some observations showing we did test protein, but we observed a very high expression of these genes, IL-1, caspase, inflammasome. And now I am in doubt. Should we treat or not treat this inflammatory response, in your opinion?
Well, looking first the inflammatory mediators, the treatment during 3 hours decreased the IL-6, right? And we have lower values for the both treatment protocols for IL-1. So it's just, we are just saying the p-value, of course, but the phenomenon, the reduction of IL-1, we see here in the protein expression. Of course, not with a statistical significance, but we see the phenomenon here in IL-1 and IL-beta, in IL-6. Regarding the gene expression, as I mentioned in the previous discussion, we have to keep in mind it's a photo. Of course, we can use the gene expression to predict an inflammatory response in the future. Depends the time we are analyzing the gene and the protein expression. Here, 6 hours of the brain death, we see the higher expression of the protein. Probably with 2 or 3 hours of the brain death, if we collect in a sample of this organ, we can see the difference among the groups. The higher the expression of the protein and the inflammatory mediators in brain death group, possibly or not, the reduction in the gene expression in the treated groups. But here we are discussing the 6 hours, the final result of the brain death. And here, the protein expression is higher in the brain death group. In the treatment group, and the treatment with Estradiol was able to reduce the inflammatory mediators. That's the reason why I strongly believe the positive effects of my treatment in order to reduce and modulate the inflammation.
I see. Okay. I am a little bit worried about you found that, for example, acute tubular injury molecules like KIN1, pro-inflammatory cytokine IL-6, they change it, and as expected in the hypox-ischemic kidney. And I think that we found this in the kidney that is waiting for be implanted in the recipient. But you showed that there is no problem with this inflammation, because once you treat them, you see that despite an inferior renal flow, you couldn't find many differences in the inflammatory markers that you tested, and you couldn't find difference between male and female regarding renal function. So again, do you think that this acute kidney injury could let's say, reflect the outcome post-transplantation?
First, I don't remember the author, but there is an article discussing the reduction of Estradiol resulting in poor outcomes in the renal transplantation. It's something I don't remember now, but I can send you after the defense. But the author discussed this reduction in the clinical with the poor outcomes in at least in renal perfusion and renal transplantation. And regarding, you are discussing the chapter 6, right?
Yeah.
The effects of the brain death. Here we see not my thesis discuss two kind of brain death model. There is low and the fast induction. We see the inflammatory response in both models. So the inflammation in the injury triggered by brain death we see in both models. So I believe the estradiol reduction observed in the fast and the slow modulate the inflammation observed here. So we see in the estradiol treatment there, in the estradiol treatment modulating this inflammation. And we didn't put the data regarding the estradiol measurement in the chapter 6, but I believe we could see a reduction of estradiol.
Okay. Well, all this taken together, your results, we can ask the key question. Are there differences among female and male donors? Because, as you know, the UNOS, the last report of UNOS, and many other clinical trials evaluating outcomes that at the end is what matters. The outcome is based in donor and recipient matching, you know, female to male, male to female, etc. We're not able to demonstrate such difference in the short and the long-term follow-up. How to reconcile these general finds? I know that there are some studies showing difference, but I would go much more in the direction that Professor Moyer said. There are confounding factors like size, weight, or body mass index, and some immunogenicity difference between organs, heart and lung and kidney. And the fact is that most of, in general, we at least at the present time, we cannot assure that there are differences in outcomes between matching male and female. As Professor Moyer said, it would be an interesting information regarding the small bowel transplantation, regarding the microcirculation. But until now, I think we got very interested in this problem in the last decade. And in my opinion, and now the general consensus is that we cannot find these differences. So how do you put your data, you reconcile your data with this general idea that we have?
Well, of course, we are using, due to the reduced viable organs for transplantation, we are using some organs not with high levels of injury in order to help and support the people in waiting list for transplantation. But idea here is give an organ good enough to transplant, and then the recipient have a life normal life. Regarding the genes, the sex differences, the literature describe a difference. And why we are discussing mainly estradiol? Estradiol modulates the inflammation in the woman with all content, all systems. We see lower incidence of the cardiovascular disease, and the glomerulonephritis is present more incident and lower incidence in females. The estradiol is presenting the woman as a protector. And that's the reason, possibly the reduction in the clinical, we correlate with a higher inflammatory response. And then there are several studies discussing the quality of the organ from female donors. We see here also the inflammation triggered by brain death in female donors in the clinical situation. That's a reason there are several articles also discussing the outcomes to male recipients that receive organs from female donors. This man doesn't have enough estradiol to maintain this inflammation triggered previously. That's the reason we see a good outcomes to female donors, to female recipients. Probably these female recipients, we have women's premenopause. And in the environment of the recipient with estradiol was able to maintain this organ without an inflammatory process triggered previously transplantation. So I believe in the gene effect in the donation. And discussing more critical these studies, the clinical studies with showing not significant difference between males and females in the outcomes, the sample analysis, the population is a bit smaller. We see a huge clinical studies as Kazmarek discussing the heart transplantation and Sato discussing the lung transplantation. We see with a huge population differences between the match in the poor outcomes to male recipients that receive organs from female donors. In all articles, they are suggesting an important effect of the environment between the recipient, the donor, and the recipient. That's the reason came the idea discuss the hormone effect. Once the hormones modulation, the inflammation in the woman, possibly the reduction could be a trigger for the inflammatory response in the woman donor. But of course, discussing more these topics could be relevant and to preserve or discuss more the effects of the brain death in the recipients and the donors, of course, could be give more ideas to give a north to the treatments, possible treatments to modulate this inflammation, and we have more, the better outcomes in the recipients.
I see. Well, anyway, it's a controversial issue, and it's good that it's controversial because otherwise we won't be here to discussing this. Well, finally, in your chapter 7, I fully agree with the future perspective that you offer us. And I dare to answer to Professor Moyers and to you that we are going back to the years 70s, 80s, where the pre-treatment or preconditioning of the brain dead donors was at that time an idea that it was not feasible because the machine perfusions were not so good and the machine perfusion was stopped. And now we have good machine perfusions and pumping these kidneys. I believe kidneys classified extended criteria or kidneys classified with a very high KDPI, perhaps with a cocktail with estradiol, steroids, and IL-1 blockers, certainly will improve the organ donor pool, and especially kidney, that you know that we have a very big ischemia time in Brazil, and this is very, very bad for the kidney. So I am really at my age convinced that we are achieving this idea going back to the previous years 8 and 70 and 8. I appreciate reading your thesis. You got a very large volume of information and data. And in my opinion, you are ready to continue your scientific work. And you are twofold tested in this thesis process in Groningen in Brazil, and you more than deserve this PhD title. Congratulations for your work, and thank you again for inviting me. Good luck.
Thank you, Professor Abud Filho, and you gave me a lot of insights in order to study the kidney, and I, of course, keep this all suggestions in mind in my future. Thank you again.
So now, in order to continue, I will ask Professor Nassad to take the word, to open the microphone. It's your turn then to make the questions and ask the candidate about your questions. Thank you, Professor, for being here.
Thank you, Anna. Thank you. Can you hear me well?
Yes, very well.
Okay. First, as a cardiac surgeon, I would like to thank the post-graduation committee for the invitation to participate as a member of this very noble band. It's a great honor for me to have the opportunity of evaluating this remarkable work about the effects of estradiol on brain dead rat organs among distinguished professors Moyers and Mario Abud Filho. Needless to say, Armstrong Jr.'s thesis is simply a very comprehensive and meticulous research regarding a new strategy to better preserve the quality of transplantation organs. Under outstanding mentorship of Ana Cristina Tralopa, Henry, and Luis Felipe Morel. I beg your pardon. I would like to continue in Portuguese, if you don't.
Yeah, sure.
It's completely possible. You can change to Portuguese.
All right. Well, I have some thoughts and questions in English, and then I'll move on in Portuguese, okay?
Okay.
Is there any simultaneous translations for the...
Unfortunately not.
No, oh, all right. Sorry about that. Well, let's start with English. After this short introduction regarding the title, that it would be interesting to include the term an experimental study in rats, like the whole of estradiol and the maintenance of brain dead rat organs.
Okay. Yeah, I think it's something we discussed in the. Sorry, can I answer in Portuguese, right?
Yes.
A gente tinha discutido em colocar um estudo experimental como título da tese. É algo que poderia, sim, ser colocado de forma a deixar claro que é experimental e não clínico, e poderia com isso concluir que eu acredito no tratamento com estradiol, fazer essa transposição para a parte clínica. Então, de fato, colocar experimental no título da tese poderia deixar mais claro para o leitor.
Okay. In chapter 1, you have made a very wide review about worldwide literature, driving the reader to the effects of estradiol on systemic inflammation and the potential of therapeutics in organ preservation for the heart, lungs, and kidney transplantation. In page 8 of the book, second paragraph, just below figure 1, you've mentioned that estrogen protects cells against the prevention of atherosclerosis. I don't know if I quite understood well, but it wouldn't be better to replace prevention by development, the word prevention by development. You get the meaning?
Se eu entendi bem, é que a conexão não está...
O seu microfone, professora Assad, está dando umas
Uma interferência.
falhadas, está com um pouquinho de interferência.
Tá. Na página 8, debaixo tem uma frase aí que você colocou que o estrógeno protege as células endoteliais contra a prevenção da aterosclerose. Não seria o desenvolvimento da aterosclerose?
Falar que o estradiol protege as mulheres em caso de aterosclerose foi uma forma de introduzir o assunto, mostrando que o estradiol ele exerce uma ação protetora no endotélio da aterosclerose, que também é um processo inflamatório, né, de forma a proteger o endotélio de uma possível inflamação. Então, a gente viu a incidência de doença aterosclerótica é menor em mulheres pré-menopausa, uma vez que o estradiol endógeno protege o sistema cardiovascular.
Então, eu entendi, mas você coloca que o estrógeno protege contra a prevenção. Então, é um esquisito isso, entendeu?
Tá. Entendi. Tá, entendi.
Isso que eu quis dizer. Eu acho que
entendi a sua colocação.
protege as células a favor da prevenção da aterosclerose, não contra. Ou você contra o desenvolvimento da aterosclerose, né?
De fato.
Certo. Bom, no capítulo 2 ainda, a respeito da microcirculação intestinal, na página 21, no último parágrafo, o grupo de ratos machos apresentou um menor número de células inflamatórias que o grupo de fêmeas. Você não esperaria encontrar o oposto? Eu não entendi exatamente esse achado. Você poderia comentar sobre isso?
A gente discutido isso. Um possível mecanismo por trás do porquê que tem um menor infiltrado no macho poderia ser o fluxo. O fluxo reduzido no macho poderia estar entregando menos leucócitos a serem aderidos e transmigrados. Por isso, talvez, um mecanismo pelo qual a gente tenha visto menos infiltrado no macho. Porém, a inflamação vista não só no intestino, mas também no pulmão, em outro trabalho publicado pelo grupo, também evidenciou um aumento do infiltrado na fêmea e um menor fenômeno no macho, relacionando com uma maior resposta inflamatória na fêmea. Mas uma sugestão, uma hipótese pelo qual a gente viu um menor infiltrado no macho pode estar correlacionado com o menor fluxo na microcirculação no macho.
Professora Sádia, a sua câmera está tocando.
Não, é que a página em cima do...
Ah, tá.
Só isso.
Estava um pouco estranho.
Uhum. Bom, na discussão do capítulo 2, na página 26, no final do penúltimo parágrafo, a expressão gênica de endotelina 1 é maior no grupo de fêmeas pectomizadas. Pelo fato da concentração do estradiol ser maior neste grupo, estradiol não deveria inibir a síntese de endotelina 1?
Bem, a redução do estradiol levou a uma maior resposta inflamatória observada na expressão da endotelina 1. O que a gente discutiu foi que a concentração do estradiol antes da morte levou à manutenção, o estradiol antes da morte levou à preservação da expressão da enós e não teve a queda da enós após as 6 horas da morte. Porém, a resposta inflamatória engatilhada pela morte levou ao aumento da endotelina, que está correlacionada também com a expressão de mediadores inflamatórios. Por isso que a gente correlacionou o aumento da expressão da endotelina com o aumento da expressão da INCAN, a maior interação do leucócito com o endotélio e o impulso das células inflamatórias para o tecido do intestino.
Ok. Sua tese está maravilhosa. É um livro, é um marco aqui para a nossa faculdade, um estudo bem abrangente. E, assim, eu não sei se você pretende corrigir alguns apontamentos dessa arguição, mas se, porventura, você for republicar a tese com as sugestões e correções, tenho algumas correções nas legendas das figuras. Por exemplo, na figura 2 da página 40, quando você coloca 40 vezes para todas as imagens, saiu 49. Eu acho que na página do texto tem essa falha aí. E as letras A e B, alfa e beta, na significância estatística, saíram num formato normal e não como símbolos. Então, se você for republicar a tese em formato de livro, acho que valeria a pena você corrigir. E isso se repete em todas as legendas, tá?
Eu acho que o que a gente, devido à pandemia, a gente não está entregando a versão física para a biblioteca. O que fica registrado no acervo é a versão digital. E na versão digital, que o programa acabou mandando para todos os membros da banca, é a que tem todo o artigo completo, correto? Então, nesse arquivo PDF, que tem o paper todo completo, eu acredito que essas falhas não vão estar presentes.
Okay.
Foi só a forma que eu passei para a versão do livro, que deu uma alterada, mas eu agradeço pelas sugestões e tá arrumando.
Na página 42 do livro, no último parágrafo, foi demonstrado um aumento de volume diastólico do grupo tratado com estradiol. Ocorreu também um aumento do volume diastólico no grupo de morte cerebral não tratado. Essa diferença não foi estatística, porque pela avaliação visual aqui, me parece que o comportamento é muito semelhante aos grupos estudados, né?
O que a gente observou de alteração da função foi da fração de ejeção. E o tratamento ele não alterou muito a função cardíaca pelo fato que ele não altera a hemodinâmica. A gente viu uma melhora da função cardíaca no tratamento publicado pelo Dr. Daniel Magalhães, que ele fez o tratamento dos doadores, que nesse caso foram ratos machos, com salina hipertônica. E uma vez que a salina hipertônica ela melhora a hemodinâmica, a gente vê uma melhora da função cardíaca, que não foi observado aqui. Uma vez o estradiol, ele não altera a hemodinâmica como um todo. Ele acaba focando mais na resposta inflamatória.
Embora tenha sido observada, né, uma variação do volume diastólico final de 194 para 270, né, as médias, né? É uma variação, é uma tendência, é uma dilatação ventricular importante, né? Você não tenha encontrado diferença estatística entre esse dado basal e final, não é isso?
É isso aí.
Na página 54, no primeiro parágrafo, em que momento foram colhidas as amostras de sangue para quantificar o estradiol e a corticosterona? Aí você não menciona em que momento...
As dosagens são feitas sempre ao final do
experimento.
A gente dosou, porque foi o mesmo dado apresentado no paper do coração. A gente não poderia, a gente teria que colocar nesse paper de outra forma para não ter conflito. A gente colocou em forma de texto, mas a gente dosou 3 e 6 horas de estradiol e corticosterona. A gente tinha um acesso para coletar a amostra de sangue, então a gente coletou inicial, 3 horas e 6 horas.
Tá. Em relação à quantificação do edema pulmonar, na página seguinte, eu vi que você, depois da ressecção de fragmentos do parênquima pulmonar, você promoveu a desidratação do tecido e avaliou o peso seco. Você chegou a fazer a variação de conteúdo de água para avaliar, seria mais um parâmetro para quantificar o edema pulmonar, né? Você chegou a fazer?
Fiz uma relação peso úmido, peso seco, para falar do edema.
Pois é, mas aonde está essa informação?
Foi só usado para azul de Evans, que uma vez que o azul de Evans, ele é uma macromolécula, ele se liga à albumina, e quando tem um extravasamento para formar o edema, a albumina ligada ao azul de Evans passa. Então, a gente depois colocou esse órgão na formamida e quantificou o quanto que tem de azul. E foi correlacionado. Quanto tem de azul, o quanto que tinha de edema pulmonar.
Ok. Não, eu entendi. Eu vi que você quantificou o edema, mas esse dado de variação de conteúdo de água, você não colocou aqui no resultado, não é isso?
Não.
Não, né? Tá. Seria uma informação para corroborar aí a sua avaliação de edema pelo azul de Evans, né?
Tá.
Mais um dado interessante. Na página 57, no terceiro parágrafo, você fala que o corante foi injetado 20 minutos antes do fim do período de morte cerebral. Não ficou bem claro para mim quanto tempo o balão permaneceu insuflado.
O azul de Evans ele foi dado 20 minutos antes para seja possível avaliar o edema, mas não tem a ver com o balão. O balão para induzir a morte encefálica, a gente insufla ele e mantém ele insuflado durante as 6 horas.
Uhum. Tá. Mantém o balão insuflado?
Isso.
6 horas do procedimento?
Isso.
Ah, ok. Na página 60, na figura 2, você coloca aqui esse critério do azul de Evans, né? E agora, tanto na apresentação da sua aula, que foi brilhante, foi magnífica, foi bem didática, como agora ficou mais claro para mim.
Ah, perfeito.
Na página 68, no segundo parágrafo, quanto tempo você levou para induzir a morte cerebral? Quanto tempo você constatou a morte cerebral após a insuflação do balão?
A gente faz, insufla o balão, vê como a gente canula para ver a pressão do sistêmica do animal, a pressão arterial média. Como tem a descarga de catecolamina, a gente vê o pico hipertensivo. Então, esse é um indicador nosso, que é a pressão arterial. A gente faz o teste da dilatação da pupila, para ver se tem amidez bilateral, e faz pequenos beliscões na pata para ver se tem reflexo. Tendo essas três eventos confirmados, a gente assume que o rato já está em morte. São eventos já estabelecidos como indicadores da morte.
Ok. Na página seguinte, eu queria saber em quais momentos vocês quantificaram a ureia e creatinina. Quando que vocês retiraram as amostras sanguíneas? Também em 3 e 6 horas?
Não, a gente só coletou o soro para dosar a ureia e creatinina. Deixa eu só confirmar, mas foi ao final. Foi ao final. A gente coletou o soro no final às 6 horas da morte cefálica e dosou.
Na página 96...
Ah, a gente tem inicial e final, né? Desculpa. Então, no tempo zero, né, assim que teve a morte, a gente coletou sangue para dosar no soro e ao final.
Ok. Só mais uma sugestão, se você, porventura, for republicar, na página 96, a referência 12, eu acabei interessando por ler essa referência e não tinha ela está incompleta na página 96, então precisa completar. Na publicação está correta.
Eu peço desculpa pelo equívoco, se tiver interesse eu posso encaminhar o trabalho, o senhor dá uma lida.
Beleza. Eu já consegui, obrigado.
Ah, perfeito.
Obrigado. Na página 112, conforme o professor Mário já apontou, né, os gráficos são muito pequenos na impressão da tese, né? Eu tive que correr aos arquivos em PDF para conseguir ler as legendas e entender melhor os gráficos, né?
Eu peço desculpas, foi uma falha minha na hora de fazer a montagem do livro, que eu acabei pensando mais na parte digital, né, e acabei esquecendo que ele é impresso e ele não ia ficar tão legível. Mas eu peço desculpas.
Não, tranquilo. E a última pergunta, já que a maioria das perguntas já foram respondidas pelos professores que me antecederam, assim, fazendo a translação para o cenário clínico, né? Como a metilprednisolona tem sido usada nos possíveis doadores de órgãos, você planejaria, em estudos futuros, uma comparação do uso de corticoides com estradiol neste modelo de morte cerebral, isoladamente ou associados? Eu gostaria de ver nesse seu modelo de morte cerebral, que achei assim, perfeita a metodologia, queria parabenizar a professora Ana e o professor Luiz Felipe pela orientação da sua tese, e você pelo trabalho extenuante que deve ter sido essa tese, né? Eu me interessaria em ver como que seria o resultado da associação com metilprednisolona ou isoladamente, ou associada com estradiol. Seria interessante para um futuro, para essa linha de pesquisa, que é espetacular, é maravilhosa.
Sim, já tem um estudo de uma colega nossa, que por acaso é a minha namorada, que ela está fazendo avaliação da lesão nos órgãos tratando com estradiol e a prednisolona, de forma a avaliar se a combinação desses dois tratamentos poderia melhorar mais ou reduzir mais a resposta inflamatória causada pela morte. Então, de fato, o que o senhor pensou vai em linha, o que a gente tem de interesse, que é fazer essa soma dos dois tratamentos de forma a reduzir a resposta inflamatória. Mas é algo que a gente vai ver num futuro não tão distante os resultados dela.
Muito bem. Como já disse, várias perguntas foram já respondidas. Eu gostaria de finalizar te parabenizando, Roberto, pela altíssima qualidade e rigor científico do seu trabalho, que ele retrata um compilado de publicações de altíssimo nível a respeito dos mecanismos de ação do estradiol sobre os intestinos, coração, rins e pulmões, nesse modelo experimental de rato que vai se consolidar com uma forte linha de pesquisa do Lean 11. E gostaria de ressaltar que as suas 4 publicações estão em periódicos coalizados e mostra aí o nível científico do seu trabalho, né? E essas publicações, em tão pouco tempo na literatura, disponíveis na literatura científica, já somam 17 citações. Então, é digno de muito mérito e sua dedicação reflete aí toda esse prestígio que você está tendo na comunidade científica internacional. Parabéns aí pelo seu empenho, pela sua dedicação. Parabéns também ao professor Henry de Groninger pela sua orientação, pelo seu trabalho. E eu gostaria de finalizar aí dando os parabéns a todos, os membros da banca também, pelas excelentes arguições, pelos excelentes questionamentos e finalizar também agradecendo à comissão de pós-graduação da Faculdade de Medicina da USP pela lembrança do meu nome para participar dessa douta banca de doutorado. Muito obrigado.
Novamente, obrigado, professor Renato, pela presença. O senhor também já contribuiu bastante para o desenvolvimento do trabalho durante meu exame de qualificação e é uma honra tê-lo aqui novamente na minha defesa. Obrigado.
Obrigado.
So now, regarding the rules of the committee and the defense, we need to have Roberto out of the room in order to allow us to discuss the results of the arguing. And the people from the bureau has to switch off the YouTube participation. We need to call them to ask them to. They are going to switch off the YouTube in order to us have the discussion privately. So we have to call them to ask them to switch the YouTube on.
I heard you. Eu vou parar a gravação.
Okay. Will you inform me when the YouTube is